Hi, everyone. Welcome to the IBM Tech Exchange Dev Day session. My name is Simon Ravenscroft. I'm a Senior Product Manager with IBM Turbonomic, and I'm here to talk about continuous infrastructure optimization using IBM Turbonomic and HashiCorp Terraform. So let's get started. A few important disclaimers. I'll give you a few seconds just to digest those. Okay, I think that should be long enough. So for those that don't know what IBM Turbonomic is, I'll just spend a moment describing that. I'll get into a little bit of a live demo. So IBM Turbonomic is a leading application resource management solution. Essentially, it manages and takes care of resource management for all your workloads. And it does that by observing the entire application stack through the management tools that you have, that you're using today, such as AWS, Azure, Google Cloud. It integrates with application performance management toolings like Instana, Datadog, AppDynamics to bring in SLO metrics such as transaction throughput, response time, SLOs. And it also integrates all the way down that stack into containers. So it understands about container clusters, namespaces, workload controllers, and the nodes that they're running on, whether that's in EKS or whether that's on premises, perhaps they're VMware virtual machines running on physical ESX server hosts. Understands that whole picture. And what it's doing is it's observing all the utilization associated with that entire application stack. And it's driving you to a desired state where application performance is assured. And as a sort of side effect or a byproduct of that, it's actually optimizing your resource allocations as well. And typically today we take the safest path, which is to over provision things. And that has implications on your cloud cost bill and on your carbon cost. And so by assuring performance, we're able to accurately size those workload resources for the best performance at the optimal cost. And so that means that as a side effect, your costs come down and you save on carbon. So that's really the problem that Turbonomic solves. It's how to keep those application stacks, those resources in that desired state where you can ensure that the application is going to perform, because nobody likes a slow app, right? While also making sure that the infrastructure that application is hosted on is running as efficiently as possible. There's a QR code in the corner. Do go ahead, have a look at that. That'll take you to the main IBM site where you can learn all about Turbonomic. There's an ability to try and do a free trial up there as well, but there's loads of resources up there as well. So just to dig a little bit deeper into that, so when I think about the first stage, which is really observing the environment, we have an API-driven agentless discovery process where we integrate with, as I said, application performance management tooling. We are able to observe Kubernetes. We do have a small component that sits inside a Kubernetes cluster to observe what's happening inside that cluster. We integrate with all the main cloud providers, AWS, Azure, Google Cloud. And we operate really a true hybrid multi-cloud approach. And we also have connections that we're able to link into things like VMware vCenter, Nutanix, and we've just announced OpenShift virtualization as well recently. So what do we do with all of that information? Well, what we do is we then build this, what we call this supply chain, where we map everything together into a supply chain of consumers and providers. So you will have down at the bottom here the sort of fundamental infrastructure, virtual machines, hosts, and so on. You have some application componentry sitting in this level, whether that's containerized cloud native applications or things like database servers and so on. And then you have your application SLOs, response times, transactions, and how they relate to individual business applications. So you may be thinking, well, okay, what do we do with all that data? Well, part of the analysis is where we bring in all that observational data and we basically analyze that to get to that perfect desired state where we're assuring performance at the optimal cost. And the output from that analysis are trustworthy actions that you can actually automate off. So the hard bit about operating infrastructure today is the decision. What should you do? How big should things be? Where should they be placed? Should I start or stop this thing? Do I need to provision more? What if I did this? So Turbonomic is able to actually generate these decisions for you so that you can then trust them to hang automation off. And the kind of decisions that Turbonomic drives is intelligent scaling actions, sizing actions. What size should my virtual machines be if I'm running on-prem, for example, or scale them in the cloud? What instance type should I be? Factors in things like ROIs and discounts and all of that good stuff, and actually attaches a cost to those as well. On containers, where should this pod live? Where's the best place for this particular pod to be placed? It also has parking capability. So not all your workloads need to be up all the time. So you can set up parking schedules in Turbonomic to take care of that and park certain workloads to save a bit of money there. Just to dwell on this moment, all of this is an abstract model. So you can think of this as like your digital twin of your application infrastructure in your environment. And that enables what-if scenario planning. So by creating a digital representation of your infrastructure, you're able to say, well, okay, what would happen if I picked up, for example, this VMware host cluster of virtual machines? What would that look like if it was running up on Azure, for example? How much would that cost me if I just lifted it up and shifted it up onto Azure? And then how much would that cost me if I actually then optimized it on the way? So it gives you very powerful different what-if scenario planning. The automation part of it, essentially, you can automate inside Turbonomic. We have an automation, it's a policy-driven automation engine, so you can set up some basic workflows in there to actually automate in Turbonomic and actually execute those through its direct native connections into those management platforms, so into AWS, into vCenter, for example. You could manually just click on the actions and execute them in Turbonomic as well. You can schedule them into maintenance windows. You can also use a capability called webhooks to actually trigger external APIs. And that's typically the path that you would take if you want to, for example, post one of those decisions into a Microsoft Teams Slack channel. So you could do that. We also have a native integration with ServiceNow, so you can raise change requests as well. So let me just take a moment and see if my demo instance is actually up. I might actually have some demo gremlins here, but let's see how it looks. Just bear with me a second. Let's just see if we've got one here.
Oh yeah, and feel free to ask questions in the chat. We'll answer them.
Thanks, Joseph. Right, let me see. I'm going to hop over to a different demo instance. Right, so what you're looking at here is the Turbonomic user interface. You're seeing the supply chain right here. So this is actually, these are actual pods and applications running. And what I wanted to do was really say, like, we're looking at everything here. So we've got container pods, virtual machines, there's physical hosts as well. But if I'm just interested on, say, for example, on-premises workloads, then I can filter that whole view to just look at on-prem. And I'm not seeing any sort of regions or any cloudy sort of stuff going on here. The interesting thing here is I've got actions, so I can go into the actual actions if I want to. I can see that we've got 357 scaling actions. We've got some delete actions, placement actions as well. And then I can see a summary of the host clusters that we've got, what our headroom it looks like for various different metrics and some actions. So let's go into this particular, this is a VMware production cluster. I can see here that we've got 8 hosts in this cluster, and they're running 26 virtual machines, and there's 2 business applications on that. Bit of storage attached as well. And I can see in our optimized improvements tab here that there is opportunity to de-risk a couple of the hosts here. So we can see that we've got a couple of hosts that are running at 80% utilization, and that's for memory, right? So you can see that this is the before picture, and this is the after picture. So if I took all the actions that Turbonomic is recommending in this host cluster, I would de-risk those 2 hosts and prevent performance issues from occurring. So let's have a quick look at what those actions actually look like. So here's an action right here. We can look at the move action. We can see we've got prevention. We've got things for performance. You can see for memory congestion. We also understand CPU ready as well. So let's go have a quick look at that. So now we're looking at the action details in here, and I can see the before and after and what that looks like. I could then go and have a look at, say, just this host and focus in on the host and actually just see that this host has 9 virtual machines on it, I can get a sense of the resources being used there as well. I can actually go in and just understand what's the utilization like, and here you can see the memory utilization is quite high. And I can see the actions that Turbonomic has got, moving virtual machines away from this particular host onto a variety of other hosts that have that capacity. So that's all great. Let me just go back to our cluster view. Now, I just wanted to talk a little bit about the what if planning scenario. So if I go into, let's just go in here and I can do a plan. So I'm focused on a particular VMware cluster. I can go into a plan and I can say, okay, what would this look like if I migrated all of these to the cloud? And so I can say, right, okay, I've got a couple of connections already to AWS and Azure. Let's see what that looks like if I move it all to the development account on there. And then I can specify a region if I want. I'll just go with US East, and I can just run a plan. And this is running a plan now to simulate, basically based on the actual usage of those virtual machines. There were 26 virtual machines in that cluster. What would that look like if it was running on AWS? And so that gives me a sense of what that would be. And we'll just wait for the results to come in. The suspense is okay. So now if I look at the cloud cost optimization table right here, we can see that there are 10 virtual machines with performance risks, and it's going to cost us roughly $600 a month to host that on AWS. And that's if we just picked it up and moved it straight into AWS. Now, if we optimized it, there would be no VMs with performance risks, and the cost would come down to $115 a month. So that's quite a significant saving. So this actually gives you a bit of a heads up as to what that would cost. You could run the same thing against Azure in different regions to see how that all works out. The important thing is that it also gives you a set of actions that you can take, and it's recommending specific instance sizes based on the actual demand that these virtual machines have. So it gives you a migration plan to follow, and then obviously you can take that offline, you can download it and try it out yourself. So that gives you a sense of the on-premises capabilities of Turbonomic. Let's just quickly dive into the cloud side of it. So I'll go back to our main view, focus on the cloud, and I can see we've got a similar view, and this is spanning across all public cloud providers, so Azure, AWS. So here you can see our top accounts. We've got GCP in here, AWS, Azure. I can summarize these by the potential savings. I can see there are 63 actions here. So let's go and have a look and see what those look like. So you can see at the top here, we summarize what these savings are. So you can see the savings. You'll notice there are also investments as well. Let's have a look at virtual machines. So I can see that there are potential savings here as well. And I can see scaling action. So let's go back. I just want to go back to the AWS or the Azure one. Let's have a look at some of the actions on here. Actually, I'm going to go back to the, this one, that was the one I was looking for. Yeah, okay, so, and we can go and see that we've got pending actions in here, we've got scaling actions and so on. So let's go and have a look at some of the actions in here. And if I look at the scaling actions on virtual machines, you can see we categorize these up in different categories for savings or performance. We've got 27 of these. So if I go and have a look at one for performance, for example, we're not just considering reducing costs, we're also saying you need to size things up perhaps, or even size things down for performance reasons. So the nice one is where you get a resize down action or a scaling action down to actually improve performance because we're changing the instance type. So in this case, we're changing it from a B1LS to a B1S, which is going to give it a bit more compute capacity, which will reduce our vCPU utilization. But the issue here is the memory. It's at 97% with 512 megabytes. So we're going to give it another gig by changing this instance type, and it tells you how much extra that's going to cost. It's going to go up by a fraction for that. You're able to execute that right here if you wanted to, and we have all the tagging data and everything associated with this as well. Like I say, there is parking capability in Turbonomic as well, so you can set up schedules. You could set up a schedule to park certain workloads at certain times in a certain time zone, and then apply that to specific workloads that you've got. So you can do all of those things. Okay, so that's Turbonomic. Obviously, feel free to ask any questions in the chat. Let me flick back to the presentation. So, thinking about Turbonomic in the context of where you're describing infrastructure as code in an application engineering environment or an SRE or a DevOps environment where things are described as code, you're building applications to meet business need. Today, organizations are software houses, right? You've got application teams, product managers, building software for the business to meet business objectives. It's complicated. Building applications is not easy. It's pretty hard, and it's getting harder, right? The complexity that has come out of containers, for example, and some of the cloud native technologies in serverless is all quite a lot to take in as an engineer. On top of that, you're expected now to be mindful of cost and understand resourcing. And the great thing with Turbonomic is it was built to do that job automatically without human intervention. And so you can lean on Turbonomic to take care of managing cost, taking care of managing those resources, which enables you to focus on your core objectives, on your main mission, which is to really build great software that really tackles business outcomes. And this moves the organization closer towards what we call zero ops or no ops concept, where you're just focusing on what you need to do rather than managing the things that you've done. So when I say it's all in the code, I just wanted to touch a little bit on what I mean by that. And so what we've got is essentially things described as code using typically Terraform has been pretty viral out there and has had massive success, enabling engineers and SREs to stand up infrastructure really quickly. And so Terraform will use the actual configuration, the resource definition described as code to rapidly deploy workload into things like AWS and public cloud. That's all great. What if someone then goes and changes dynamically the thing that's in AWS or in Azure, changes that instance type without actually changing the code? Well, that's where drift comes in. And drift is where what is described as code and what is actually running and deployed by Terraform don't match. And so that can be a bit of an issue. It's important to resolve that drift so that unscheduled, unplanned changes are highlighted and understood. And so that's an important thing to do. So one of the things with Turbonomic, being a dynamic resource manager, it's actually operating on the deployed instances. So it will, if it's enabled to automate or you execute, it will actually create that drift for you. So what I wanted to do was get into some of the solutions that we've got to address that. And the first one is the IBM Turbonomic Provider for HashiCorp Terraform. And so this allows you, as an engineer, I can code in the use of the Turbonomic Provider, which is essentially saying, for this particular resource, I want to delegate responsibility for managing that resource in terms of its resource values, the instance types, and cloud tiers to Turbonomic, which means that by using that provider and codifying that, whenever you do a Terraform operation, whenever you run a speculative plan or an apply, Terraform will actually use that provider to go fetch the data from Turbonomic to find out what the optimal size should be for that particular resource. It'll then use that when it deploys it, which means that the actual deployed resource is always at the optimal size. It also means that within Turbonomic, you can actually safely enable its own native automation capabilities directly against what's running. So you get that real-time optimization without creating the drift that you would normally get, simply because Turbonomic is now the single source of truth there. The Turbonomic Provider is available today on the Terraform registry. There's a QR code there and a short link to that. You can just go search on the registry. I'll show you what that looks like in a second. It's open source, so it's also on the IBM GitHub, public GitHub. Obviously, you need IBM Turbonomic at the back end for it to be of any value. But let's go and see what that looks like. Just have a quick dive into the actual page there to see what that looks like. Bear with me. Right, so we're on the Terraform registry page here. Here's the Turbonomic provider. we've got documentation here that goes through, describes how to configure it, the credentials. You can use OAuth 2 as well now. So we've added that fairly recently. There's some examples for AWS, some simple examples to follow, and Azure as well as GCP. So let me flick back, and I've got a small demo video that I can show. So it's really aimed at platform engineers and application teams to delegate that responsibility to Turbonomic. So let's go and have a look at this 8-minute demo video, and hopefully you'll all be able to hear this. So here we go.
Hello, everyone. Thanks for joining us. Today, we'll uncover how integrating Turbonomic intelligent analytics with Terraform workflows transforms how you manage cloud resources. The problem is that we all see chaos and increasing costs that happen when teams manually resize instances or lose track of who changed what. Rather than endless manual adjustments and surprises, our integrated solution continuously and proactively optimizes resource usage, ensuring performance, cost control, and predictability so your team can refocus on innovation. The value is automatically optimizing cloud resources to achieve significant cost savings, eliminate drift, and enhance performance predictability.
If you browse to the Terraform registry and search for Turbonomic, you'll find our provider. Under the documentation section, you'll see examples on how to configure and implement the provider for AWS, Azure, and GCP. Let's flip back to the code. As you can see, we've added a few blocks. The first being the required providers block, which specifies that we're going to be using the IBM Turbonomic Provider. We then configure that provider by passing it the hostname, username, and password of the Turbonomic instance. Note, I'm using variables for these values. You can also pass a skip verify equal true if you're using self-signed certs, so that the provider doesn't validate the certificates from your Turbonomic instance. Next, we need to create a data source block, specifically of type Turbonomic Cloud Entity Recommendation. And the values from that data source will be stored in a variable called example. We then need to pass the name and the type of the entity in which we're asking Turbonomic for the recommendations for. Notice that my entity name matches the name of the virtual machine in my resource. The last piece of information we need to add is a conditional statement within the instance type. What this statement is saying is that if the data source responds and has a new instance type that does not equal null, use that instance type value for the instance type in the resource. If it is null, which means that the entity doesn't exist in Turbonomic yet, then use a T2 nano as a default. One other thing to note is that if the entity does exist in Turbonomic, but there are no recommendations, the value returned will be the current instance value. Now that we've configured our Terraform code to use the Turbonomic Terraform provider, let's see if Turbonomic has an action for our entity. And indeed it does. Turbonomic suggests that we take the instance type from a T2 nano to a T3A nano so that we can realize some savings. So now that we have an action, let's go to the command line and run a Terraform plan. And as you can see, just as we saw in the Turbonomic UI, Terraform is now showing that the instance needs to be changed to a T3A nano. This is because in the background, Terraform is accessing the Turbonomic provider, which is asking Turbonomic for a recommendation on the size and setting that to the instance type. And this is how the Turbonomic provider can be used to be the source of truth for your sizing in your Terraform environments.
Let's talk about the broader impact of this automation. FinOps can set their cost or utilization parameters in Turbonomic, and the provider ensures these guardrails are enforced. Platform admins love that they don't have to tear apart existing pipelines. This is basically plug in and play with Terraform. Developers are relieved that their resources stay healthy and cost efficient without constant manual tuning. In other words, This is a solution that satisfies all stakeholders, fueling both proactively and financial discipline. Ray will now demonstrate Turbonomic dynamic scaling.
Now that we're using the Turbonomic Terraform provider in our Terraform code, we've essentially created drift in Terraform. This is because Turbonomic is recommending that we change the instance type for this VM to a T2 nano to a T3A nano. However, if we execute the action within Turbonomic, we eliminate that drift. This is because Terraform is still utilizing our provider to determine the instance type of this VM. So after we execute the action, when we then run Terraform, Terraform will compare what Turbonomic says is supposed to be the instance type and what's been deployed in EC2. And since they match, the drift is eliminated. Let's go ahead and execute the action. Now that the action is completed successfully, let's go to the command line and run a Terraform plan. As you can see, because Terraform is configured to utilize the Turbonomic Terraform provider, after executing an action in Turbonomic, we've created no drift in Terraform. For the last demonstration, we're going to show how you can utilize the Turbonomic Terraform provider in your Terraform code and take advantage of the actions that Turbonomic's generating, but execute on the Terraform side instead of the Turbonomic side. Okay, so as you can see here, we have that same VM. It's been deployed through Terraform using the Turbonomic provider, and we have a scaling action, again, to take it from a T2 nano to a T3A nano so that we can realize savings. Let's switch to the command line and run a Terraform plan. Okay, so as you can see, Terraform is picking up the action from Turbonomic. Because Terraform is configured to use the Turbonomic provider, when we run this plan, it's checking Turbonomic to see if there's any pending actions for this VM. And since Turbo is suggesting that this VM be resized to a T3A nano, we're seeing the results in the Terraform plan as well. So let's go ahead and execute the action by running a Terraform apply. Now that Terraform has successfully resized the VM, let's go back to Turbonomic and refresh the console. We see that the action is no longer present, and if we scroll down a little, we can see that the cloud tier or instance type is now set to a T3A nano, just as we expected from Terraform's execution. Let's do one more thing. Let's go back to the command line and run a Terraform plan one more time. And there's no drift. And this is how you can utilize the Turbonomic Terraform provider within your Terraform code to take advantage of the optimizations that Turbonomic is recommending.
We've all seen how Turbonomic Terraform provider puts analytics-driven optimization at your fingertips. Applications are assured the performance they demand at the optimal cost. Drift becomes a thing of the past, and your team can finally align on a single automated process for resource management. If you're excited to get started, check our provider in Terraform registry or scan this QR code for step-by-step instructions, or contact us for a deeper dive. Thank you for joining us today. We can't wait to hear about your success stories.
Okay, so that was a quick demo of how you use the Turbonomic Terraform provider in code. We've refreshed it a little bit since then as well. So where you saw that conditional logic where you had to specify a default T2 nano, you can just do that in the provider declaration now. So there's a backstop. So it's a little easier. We're iterating on this all the time, which is why that video had that in there. But I wanted to talk a little bit about the topic of, well, not all workloads are the same, right? And we recognize that. Maybe some workloads you don't want to use a dynamic resource manager like Turbonomic against to actually automatically make these changes. But there are environments where this is really suitable and where actually most of the cloud savings and most of the cloud cost lives. And that's in development, UAT, testing, and some production environments. But typically that's where the bulk of the cloud cost lives, is in those workloads. And it's also where you typically don't really want to deal with resource management so much. And so those are ideal opportunities to use the Turbonomic Terraform provider to actually just let Turbo take care of the resource management in those environments so that you can just go ahead, build fast and hard, and deal with the actual business requirements that are coming inbound and deliver great looking applications to solve for those things. Where you can't do that is where you typically need some additional governance. And I've put a label on this and called it accelerated governance. And the reason for that is that we have another part of our story with Turbonomic, with HashiCorp Terraform, which is to bring code context into Turbonomic. And that allows you to accelerate the governance process around perhaps production, business critical, sensitive workloads, where you need to route them through to, for example, ServiceNow, or you need to post a message into a Slack channel to get someone to process that action and actually approve it. And so you can do that now with this code context solution, and I'll explain what that is in a second, which will essentially bring situational awareness to the actual action details, which will allow you to process that action much faster, whether that's with your own human eyes or whether it's in an automated external workflow. And we're calling that our code context, and we do that by integrating directly with GitHub and with Terraform. So let's go and have a look and see what that looks like. So bringing that code context allows you to process that action faster. Turbonomic integrates directly with GitHub initially, and we're expanding that to add support for GitLab and Azure DevOps and Bitbucket and other version control systems. But by integrating directly with GitHub, Turbonomic is able to scan across the organization in a read-only way to find out which of the repositories of code that contain HashiCorp configuration language, or HCL, which is the language that Terraform uses to describe those code, describe resources so that it can deploy them. And then when we identify the repositories that have that in, we do a deeper Terraform-specific discovery into those repositories to identify where the state files live. Now, state is something that Terraform maintains. Whenever it deploys something, creates a state file, stores that typically in an HCP Terraform workspace or a Terraform enterprise workspace, where it's actually tracking what it deployed. So it knows what it deployed. It's got all the unique reference numbers in there of AWS instances, for example. Those are all contained inside that state file. If Turbonomic is granted read-only access to that state file, Turbonomic is then able to make the connection. It's able to correlate between what Terraform has deployed, what Turbonomic is already observing and optimizing, and the GitHub code, which is describing what has been deployed. And by bringing all that together, when you're viewing actions in Turbonomic, you're able to see that code context to give you that situational awareness. So what does that look like? So there's a couple of screenshots from the Turbo UI here, and you can see that on this particular action details, which we saw earlier, we've now got a blue box, an information box that's telling us this particular virtual machine is described as code and managed by Terraform. That's the first thing. Not everything might be managed by Terraform. So the first thing you want to understand is this a virtual machine that is managed by Terraform? Is this an application resource managed by Terraform? And then the next thing you want to know is, well, where does the code live for this? Where's the HCP workspace for this? And so we provide that directly in the action details with a clickable link to take you straight there. The other thing that happens inside Turbo as well is once that connection is made and that correlation between what Terraform deployed, what Turbonomic is already observing and optimizing, and the code, we're able to bring all that together and show a supply chain of a repository with a connection to a set of virtual machines described as code, and all the applications stack above it and below it, and really correlate all of that together, which is great because if you're a user and you're focused on a particular set of repositories, you could scope down the user interface in Turbonomic to just your area of interest, focused around the repositories, which is typically where you live as an engineer. So, got a quick demo. There is a QR code to a demo video here, which I can show. But let me just see how my demo instance is looking. It was a bit sick before I started here, but let's see. I'm always optimistic that things will work out. So let's just see what that looks like. Hopefully, oh, yes, okay. I think we're in luck. So again, 2 seconds. Okay. Yeah, okay, we'll just let it settle down for a bit. All right, so again, in the Turbonomic user interface, something I didn't show was the ability to create dashboards. So I've created a Terraform infrastructure lifecycle management dashboard here. And this is scoped to a set of groups that are virtual machines that are managed by Terraform. So one of the advantages of bringing code context into Turbonomic by integrating with GitHub and Terraform is we can very easily use dynamic grouping capability of Turbonomic and filters to say, create me a group of virtual machines that are managed by Terraform that meet this regular expression in a particular Git repo or belong to this organization and so on. So we can use all of those, and we can use them in combination with other dynamic filters that we support, such as tag key values, environments, and all sorts of things. So what I'm looking at here are a set of pending actions just on virtual machines that are managed by Terraform. And so if I do show all, I can actually go into our action center and I can actually see what those look like. Let me go into one here. So now I'm looking at a scaling action on a virtual machine, again, to go T2 nano to T3A nano, and I'm seeing that this is managed by Terraform. And then if we look at the virtual machine details here, there's a few things that I want to call out. One is the Git repo where the code is. Let me click on that. So once the green screen disappears, we should end up in a GitHub repository, and we do. And so in here, this is where the code lives, and I can go straight to my main.tf, which is where the code is described, and I can actually see what that actually looks like. So GitHub's a little bit slow. So I can see here that the instance types are actually variables. So I can then use this to actually go and track that back. It's in a module and so on. So, but I'm right there. I'm in context. I've actually got the code in front of me, and I can trace that back. I could then take that recommendation from Turbo, manually change the code, raise a pull request, and that would be picked up by Terraform, and then I could run and apply and actually apply it. So it gives you that situational awareness. The other thing I wanted to call out here is the actual HCP workspace as well. So we actually, this one is a resource that's managed by Terraform Cloud or Terraform Enterprise or HCP Terraform. I can click on this and it'll take me straight now into Terraform. So now I'm in Terraform. I'm just the one click away from that. And I can see there are actually two resources that are managed in this workspace. And then I can run operations. I could create a new run in here to actually go and do a plan or actually apply a change or anything. So I can go and do my operations within Terraform. If we deployed the Turbonomic Terraform provider on this particular instance, then I could do what Ray did earlier, which was to run that Terraform plan and apply, and it would pick up the fact that the T3 Nano is what is being recommended for that particular instance, and it would then just make that change using Terraform. So that's a good combination use of code context plus using the Turbonomic provider for Terraform as well. So let me go back to the Turbo UI. So I think I've covered off pretty much everything in here. Obviously, you can search for. So I just wanted to get into like, how do we do that? So the easy way we can do that is by going into the target configuration, and we simply add GitHub as a target. So you'll see that we have GitHub here. I can just go ahead, click on that. We've got all the documentation on the prerequisites required, but it's pretty straightforward. Give it a display name, put in the address of your GitHub, put in a personal access token, and you can configure GitHub to give it different rights based on that access token. At a minimum, we just needed read-only access to a repo. You might want to give it access across the organization. So having done that, what happens is basically Turbonomic will then go and discover those HCL repos. I can go into search, and I can search for those repositories. And I can see that there are 16 repositories of code that Turbonomic has already discovered. I can, again, go directly to those repos here using these links if I wanted to. And I can see that actually we've got some actions here. So let me click into one of these. And I can see that we're on a repository that, hey, nothing's stitched to it. It's sitting there all lonely on its own. So why is that? Well, it's because we haven't done that deeper discovery into Terraform yet. And so there is an action here, and we've got a grant access action. Let's go and have a look and see what that looks like. This is actually for S3, but we support S3 buckets as well. But essentially what this is saying is you need to grant access to this S3 bucket so that Turbonomic can read the state file and make those correlations. It will tell you the actual number of repositories that are referencing this S3 bucket as a backend for its state. Tells you how many state files there are and the number of actual Terraform resources that this would affect. And you can actually see the repository name and the actual location of the state files as well. So to grant access to that, I simply click add credentials, give it a display name. S3 is the type, could be HCP workspace as well. I can give it an access key and a server access key, and then that'll grant Turbo access to that. And then having done that, what will then happen is you'll see in that supply chain exactly as we saw. Let me go into one of these. So if I click on this one, you'll see that connection between the virtual machine and the repository and the rest of the related resources there. And then within that particular view as well, in the entity information, we can see it's managed by Terraform, and we can see the links to the Git repo, to the organization in HCP Terraform, and to the actual workspace as well. So that's all available just on the actual entity view here. That's also there in our target configuration as well. So we can actually look at our GitHub target that's been added here, and I can see that 21 repositories are actually accessed. But if I click on the actual discovery stage, you can see 16 of those 21 had Terraform assets in, and there are 101 Terraform assets that have been discovered in there. I can also take a look at some of the particular Terraform targets that have been added. So in this case here, we can see that we've got we've read successfully 6 out of 6 state files, and we've successfully related 6 out of 22 resources. Now you might be thinking, well, why is it not 22 out of 22? And that's simply because today we support certain entity types. You may have a lot of resources defined in Terraform that are not supported by Turbonomic. We're only going to relate the ones that we are actually optimizing. So these mean that 6 out of those 22 Turbonomic was already observing and already had observations on them, so we're able to relate those. And you can see how this relates back to the GitHub target as well. So that gives you a sense of the Turbonomic UI and what you can do in terms of once you've understood and connected with that code context, you're able to then set up automation workflows to actually automate off those. So let me hop back into the presentation. I'll skip over the video. So what does that all mean? Well, I've showed two example solutions there, 2 solutions that we have. The Turbonomic Provider for Terraform, which really activates that continuous optimization within your CI/CD pipeline without that greater change. You just need to make that code change once to use the provider, and then you're done. You've got continuous optimization happening. And then I showed you the integration with GitHub and Terraform to bring that code context to the optimization actions. And what that means is you can just automate a lot faster. You're able to process the action faster, and you can automate whether you're using Turbonomic or whether you want to do that yourself using webhook, API requests, or integration with ServiceNow. Either way, it's very easy to do that. So this is currently in preview. We're in public preview right now. The Turbonomic Provider for Terraform will be going GA very, very soon. It's pretty much GA already, to be honest. It's up on the registry there. The GitHub is in public preview right now. And if you're interested in this, then do please scan that QR code, register your details there, and we'll reach out. We're interested in your feedback, how you're using Terraform, how you're managing resources today. We're interested in having conversations around that. So yeah, I think that was all I actually had for today. Thank you for attending. Hopefully you found that interesting. And like I say, if you do have any other questions or anything, then do reach out, or I'll put that link back up on the preview. Then you can register there your interest. Yeah, so hopefully you found that very interesting wherever you are. Enjoy the rest of your day, evening, or night if it's very late. But thank you for attending this session. Hopefully you found that useful. Thank you.